All right, everybody, welcome to the video here for lesson number 9 on buying a car and a house. So the first thing you notice in this lesson, there's an opening exercise that's basically just reviewing a concept that we've been doing here for a few days now or a few lessons now. So pause the video and try the opening exercise, whether you're plugging into a calculator, doing it by hand, however you're doing it, see what you get for your answer. It's going to be a decimal. It's okay. Write your decimal down. All right, so if you did this correctly in your calculator, you should get a value here of 198.5984. If you're still struggling with how to get that value from the summation notation or the sigma notation problem, just email me. I'll be happy to explain it to you, but we do want to move on today. So big concept for today is we're going to use that formula we saw in lesson 8's lesson. We didn't really use it in yesterday's lesson, but we're going to use it today. So this annuity formula is basically a variation of the series formula that we've been working with. So what they did here was they did a little bit of algebra so that they can look at this formula in terms of the monthly payment and instead of in terms of the whole sum of everything. So here's your formula. It's never going to be something that you have to memorize. If I gave it to you on a problem set question, or if you are taking the Regents exam at some point in the future, you'd be able to see that formula be given to you. Okay, so today we just want to play with it a little bit and see what we can come up with. So number one says, Fran wants to purchase a new boat. Fran believes she could afford $250 a month. This is her monthly payment. This is R in the formula. It says, and she could afford that monthly payment for 2 years. So 2 years is a total of 24 monthly payments. That's your end value. It then says her bank charges her 5% interest compounded monthly. So anything that's a monthly payment, that interest is going to compound monthly. They don't even have to say that, which you'll actually see in the next problem. But for this one, we need to figure out what I is. So I is going to be 0.05 divided by 12. Now, if you type 0.05 divided by 12 into your calculator, 0.05 divided by 12 in your calculator, it's a nasty decimal. It doesn't terminate. It's a repeating decimal that goes on forever. So we don't want to use a decimal there. We're going to keep that value by as a fraction. Luckily, we have a calculator, so we can type everything in the calculator as is. So the question asks, what's the most expensive boat she can buy underneath these conditions? So what we're trying to solve for is A of P. What A of P is, this is the amount that you're borrowing. So if this girl, Fran, can afford $250 a month for 2 months and the bank has 5% interest, whatever value of A of P is, that's the amount of money that she can borrow to have that monthly payment. So if we plug everything that we now know in, so we say A of P we don't know, 250 times 1 minus 1 plus 0.05 over 12, all to the negative 24, because there's 24 payments, all divided by 0.05 over 12. Big nasty fraction there that we have to type in a calculator. So let's type it in. So I have 250 All right, so I have 250 times parentheses alpha y equals, if you have the fraction button, use it. It is definitely helpful here. 1 minus parentheses 1 plus 0.05 divided by 12 and parentheses to the negative 24. And then we're just going to divide that by 0.05 divided by 12 and hit enter. So there's her amount of money that she's allowed to borrow from the bank underneath the parameters that she's outlined for us. So she can borrow, so she's allowed to borrow from the bank $5,698.47. So what this is telling us is she's going to take this monthly payment of $250, pay it over 2 years, and she could buy a boat that's around $5,700. So what happens if Fran wants to buy a boat that's more than that amount of money? There are two things that she can do. She can either pay the difference. So she could say, well, the bank's going to loan me $5,698, so I can come up with the remaining value of $302 around there. Or she could recalculate and get a slightly larger monthly payment. So let's figure out what her monthly payment would be underneath the same exact parameters, but with this new loan amount of $6,000. So now I know the value of the ending value, the A of P value. What I don't know is this R value. I'm finding the R value. Nothing else changed though. So this fraction that was in our parentheses, this big nasty thing here, is going to stay just as is. So what I want to do, this is just a number, right? So the thing that we have to remember here is even though this looks kind of scary, this is just a value. If I can figure out what that value is, I can divide it to the other side to get R by itself. So use your calculator and let's type that in and see what we get. Now, luckily for us, we already typed part of this in. So if we have the new calculator, we could just scroll up, hit enter, and we could be a little bit lazy and scroll all the way across here and just delete out that 250. And hit enter, and we get about 22.79 something. So what we're noticing is that we have 6,000 equals R times 22.79 something. I want to divide that 22.79 something number to both sides so that I can get R by itself. R is our monthly payment. So in your calculator, if you do 6,000 divided by, and you can just scroll up here and hit enter, and it takes down that previous answer, we see that she would have to have a monthly payment that is slightly larger. So her monthly payment would be $263.23. So now Fran has a decision to make. Do I come up with the remaining money up front, or do I make my payment a little bit larger than what was expected? Now, all these things come true when you're buying a car or you're buying a house. I bought cars, I bought a house. So when you're calculating your monthly payment, what you're trying to figure out is how much money do I want to put up front in my cost to make my monthly payment to an affordable cost for myself. So let's buy a car. So if I want to determine the monthly payment of a car, 5-year loan, that's going to be 60 months. Annual interest rate of 1.5%. So that's every year. I want to know the interest rate every month. So my interest rate, my I value, is going to be 0.015 divided by 12. Again, not going to be a nice number, so I'm going to leave the fraction there. Then it says that the cost of the car is $19,700, but I'm putting down 10%. So what does that mean? So that means I'm giving this car company an amount of money at the beginning before I even start paying off my car. And I'm saying, I'm giving you this amount of money first, and I'm only going to borrow everything after that payment. So my first job is to figure out how much money am I actually borrowing. So if I take $19,700 and multiply it by 0.1, that's going to be 10% of that value. So if I do 19,700 times 0.1, I get 1970. And if I subtract 19,700 minus 1970, that's going to give me a value of $17,730. This is A of P. That's the amount I'm borrowing. All right, I'm not going to pay interest on the money that I'm paying up front as a down payment. So that $1,970 that I'm giving them initially, I don't pay interest on. I'm not borrowing that money. I'm giving that to them up front. Car companies and banks like that you do that, and a lot of times they actually require you to put down a certain percentage as a down payment when buying a car or buying a house, especially when buying a house, so that they're making sure that you have value in your own property that you're not really owning yet because you're borrowing it until you pay off the loan. So we have to figure out this monthly payment. So this $17,730, that's A of P. Again, I don't know the monthly payment, so that's R. I have this big crazy fraction. And we're just plugging in everything we know. So just like I did in the previous problem, I want to figure out what that big crazy fraction is. Right? So I got to type that in my calculator. So let's type that in. Let me just clear what's in here so it doesn't look confusing. Alpha y equals, get our fraction. If you don't have the fraction button, just use a ton of parentheses or type it in separately. So I'm going to do 1 minus parentheses 1 plus 0.015 divided by 12, and my parentheses to the negative 60, and 0.015 divided by 12. There we go. We get 57.7 something. So I have this 57.77 number. But I don't want that number. I want R. So I'm going to divide away that 57.77 number. Notice I keep putting the dots there. That's showing me, that's showing whoever is reading the problem that you actually know that you're dividing that whole decimal away, not just a rounded version of it. So if we go back into my calculator here and we type in $17,730 and we divide that answer that we got, we get a monthly payment of $306.90. So to buy a car of $19,700 with a 10% down payment, with all these different parameters, the bank's going to charge you $306.90 per month. Now, the next part is more of us just showing you that you can afford stuff, right? So let's take a look. So if you're buying a car, but you can only afford a $250 a month payment, right? Say your job only gives you that much money to put aside for a car payment, you still can buy this car. You might just have to put more money down at the beginning. So instead of a 10% down payment, you might have to put up, $5,000 or $4,000 to be able to figure out a monthly payment that works for you. So we're going to keep all the same stuff, but we're not going to know what the borrowing amount is yet. Because I know the monthly payment, $250, right? I can plug in all that same info, 1 minus 1 plus 0.015 over 12, all to the negative 60, divided by 0.015 over 12. Now, if you plug all of this in, that's going to tell you how much you're allowed to borrow with a monthly payment of just $250 instead of $300. Right? A lot of people do this when they're buying a car. Like I know when me and my wife go and buy a car, I go into the car dealer and I say, I want to buy this car, but I only want to spend $300 a month for my car payment. And they'll be able to calculate how much money I have to give them initially to be able to actually afford that car payment. So let's type this in the calculator and see what we get. So this one I want you to try on your own. I've shown you how to do it a couple times. Just pause the video, type it in, and see if you get the same answer as me. All right, so welcome back. Hopefully you typed that into the calculator here, and you got a value of $14,442.61. If you're not getting that value, check your calculator. You might have a decimal in the wrong spot. You might have forgot the negative on the exponent of 60, or you might have just typed in the fraction wrong. So look back and watch the other part of the video that shows you how to type that in. Now, this amount of money is what you're allowed to borrow with a monthly payment of $250. Notice the car is more than that. So if I take the original car value, $19,700, and subtract the amount of money that the bank's allowing you to borrow, oh, I forgot a 4 there, I get $5,000 $257.39. This would be the down payment that you need. So what your car dealer is going to say is, if you want this car and you want a $250 a month car payment, you got to give me $5,257.39 up front. All right. This will make your car payment lower, but you're going to have a lot more money to pay up front. All right. Let's use this same idea. Let's buy a house. When buying a house, there's really nothing different about using this formula other than the numbers are just going to be bigger. All right, so just get out of your head that it's a big number. It doesn't matter, right? You're typing it in the calculator anyway. All right, so this problem gives us a house that's $220,000 with a 10% down payment. To be honest with you, when you do start looking for a house, they're probably going to want 20% or more down. Just, throwing it out there, real life scenario. But we'll go with the scenario of 10% down. So if I do $220,000 times 0.1, let me just get my personal calculator here. That's $22,000. So to buy this house, you're going to have to give them $22,000 before you even step foot in the house, before you make a payment, nothing. So that means I'm going to borrow a little bit less than 220. So if I do $220,000 minus $22,000, my borrow amount, my A of P value, is $198,000. So that's how much I'm borrowing from the bank. Now this tells us it's a 30-year mortgage. Well, 30 years, that's going to be 360 payments. And it has a 3.6 annual interest rate, but remember, that would be if we only made one payment a year. I'm making 12 payments a year. So my I value is 0.036 divided by 12. Now, if I type that into the calculator, that's actually a nice decimal. So if I do 0.036 divided by 12, I get 0.003. So I like it when it's a nice decimal. When it's not a nice decimal, leave the fraction. This is a nice decimal, so I'd probably be better off typing that in my calculator. So I want us to figure out, again, this monthly mortgage payment. So I know the amount that I'm borrowing, $198,000. The monthly payment I don't know. I have 1 minus 1 plus this rate of 0.003 to the negative 360, all divided by the interest rate of 0.003. Again, a little bit easier to type in the calculator with all those extra fractions in there. So just like I did before, this parenthesis is just a number. Let's figure out what that number is, right? So let's type that into our calculator and figure out what that number is. I'll do this one with you. So I'll make a nice little fraction there with my fraction button. So I have 1 minus parentheses 1 plus 0.003 to the exponent of negative 360 divided by 0.003. So we get this like 219 value. So I have a value here of about 219.9 something. I'm going to divide away that 219.9 something value to both sides. That's going to cancel. And if I do that, so if I do 198,000 divided by that value, 219 something, I get $920, $900.20 a month. So I have a monthly payment here of $900.20. And you might be saying, that's not too bad. I'm going to buy a $220,000 house and I only have to pay the bank $900 a month. I hate to break the news to you, but that's not including property taxes or school taxes, which if you ask your parents are a lot of money, sometimes even more than your actual mortgage payment. So if you were to add on another $1,000 a month, there's your $12,000 a year in taxes. So your monthly payment for your mortgage is actually way higher than that. This is just the amount of money that I'm borrowing from the bank. It doesn't include all those other factors. Now, I think an interesting part here for this question would be if we talked about how much money the bank actually makes off of you. Now, this is just added information. It's not anything that I'm asking you in this question, but more of us just kind of thinking here a little bit, right? So I'm buying a $220,000 house. I'm paying $900 a month for 360 months. So if I take $920 and multiply it by 360, I'm going to get a lot of money here. So this is $324,072. So after 30 years, I'm going to pay that much money for a $220,000 house. And actually, if you think about it even more, I didn't even borrow that much money. I only borrowed $198,000. So if you subtract those two numbers, the bank is actually making $127,000 just by giving you this loan. Good business, if you ask me, right? And this is real life stuff. This is not fake. This is not made up stuff, right? The only thing that's kind of not realistic is the amount of the down payment. They probably would want more of a down payment, right? But this is all real stuff, right? I could look at my mortgage and tell you it's probably about the same amount of stuff that's going on here, okay? Let's skip number 4. It's kind of busy work, and it's similar to what we just did here. You're going to review the same kind of stuff in the homework. So we'll skip number 4 just for time. So here's your chance to try the homework. All right, use what we just did in the notes. See if you can figure out some of this stuff on your own here, and pause the video and come back and check your work. See how you did. All right, so let's see how we did on our homework. So in this first question, it gives us 2 different mortgages. One's a 30-year mortgage and one's a 15-year mortgage. Banks usually offer both of these. There are benefits to each one. A 30-year mortgage is generally going to have a lower monthly payment, so you might be able to afford that house that you really, really want because it's a lot of money and you want that lower monthly payment. A 15-year mortgage, well, you're going to pay a lot less interest because you're only getting tax interest for 15 years versus 30 years. And we all know that interest builds exponentially. So the more years you're paying interest, the more interest you're eventually going to pay. So let's take a look at 2 completely different mortgages here and see which one gives us a better monthly payment, and then see which one gives us a better amount of interest paid over the course of the loan. So let's take a look at mortgage A. So mortgage A tells us that we are borrowing $250,000, but with a 10% down payment. So if I do 250,000 times 0.1, that's going to be $25,000. So we're going to borrow $225,000. Both loans are going to be the same borrow amount. So I'm going to borrow $225,000. I don't know the monthly payment. I have 1 minus 1 plus 4.2%, so 0.042 over 12, all to the negative 360. 30 years is 360 payments, all divided by 0.042 over 12. Notice I'm using a fraction there. That's not going to be a nice decimal for us. So now I have to type into my calculator this big messy parenthesis and see what we get. So if we type this into my calculator, alpha y equals, enter, 1 minus parentheses 1 plus 0.042 divided by 12 to the negative 360 divided by 0.042 over 12. That's our number for that big messy fraction. Now remember, I want to divide that fraction or that number to the other side. So I'm going to take $225,000 and I'm going to divide that number. And that's going to give me a monthly payment of $1,100. and 29 cents. Not too bad. All right, let's talk about mortgage B. Same loan amount. All right, I'm borrowing the same amount of money. I still don't know the monthly payment, but I have a different interest value. So the interest value here is 0.0325 every month. For 15 years, well, that's 180 payments. All right, let's plug that in, see what we get. So if we go alpha y equals, let's figure out what that nasty fraction is. So we'll do 1 minus parentheses 1 plus 0.0325 divided by 12 to the negative 180. Fingers aren't working here. And 0.0325 divided by 12. So that number represents that fraction, that decimal that's multiplied to r. I want to move it to the other side, so I'm going to divide it away. So if I take 225,000 and divide that number, I'm going to get r. So in this case, the r value is much higher. So I have $1,581. Nice even number. So what we can see here is in mortgage A, I'm paying for 30 years, and I'm going to have a much lower monthly payment than in mortgage B, which I'm only paying for 15 years. Again, pros and cons. I can only afford $1,100 a month. I'm going to go with mortgage A. Mortgage B, although is a more monthly payment, I'm paying a lower interest rate. I'm going to pay less interest over time. So if I could afford mortgage B is actually going to be my better bet. And you're going to see really why in part 2. So in question 2, it asks us to figure out how much interest is paid over the course of each loan. So for mortgage A, I'm paying $1,100.29 for 360 months. So that's $396,104.40. Well, I only borrowed $225,000. So over the course of this loan, you're going to pay $171,104.40 in interest. So this is your interest paid over the course of your loan for mortgage A. That's a lot of money. You could almost buy 2 houses for that. Where mortgage B, which had the higher monthly payment, $1,581, and it had less payments over the course of the loan, that comes out to be $284,580. Well, if you subtract the original amount of money that you borrowed, you get an interest paid of only $59,580. So again, if you could afford mortgage B, go with mortgage B. It's going to, over the course of time, cost you a lot less money, right? Even though you're paying that extra amount of money every single month, right? You're paying it off the loan quicker, so you're going to have less interest. If you understand questions 1 and 2, you get the overall gist of the lesson. Question 3 is tough. Question 3 is tough because it involves logarithms, and you're going to see why here in a minute. So it tells us that we have this student loan, which a lot of you are probably eventually going to take. I know I took student loans. Student loans, when you take them, they usually have a pretty low interest rate, and they don't require a high monthly payment, right? So if you take out a student loan, your monthly payment only might be $80 a month, $100 a month for, $30,000, $40,000 in loan amount, but it's going to take a really long time to pay off. So let's see an example here. And this is actually a real life example, right, of what a student loan will look like. Federal loans are usually about, 2% to 3%. $31,000 might even be a little bit low for a loan, but you get the idea. So we know the amount of money we're borrowing from the bank, $31,000. We know the monthly payment's $100. We know the interest is 0.024 every month, so divide that by 12. The thing we don't know is n. So as soon as I write this down, as soon as I see the variables in the exponent, I'm instantly thinking logarithms. But I have a lot of messy stuff around that exponent that I have to get rid of or move before I could even start figuring out the logarithm piece of this. So the first thing I'm going to do is I'm going to divide by 100. Why? It's going to get rid of that 100 in the front. So if I divide both sides by 100, I'm going to get 310 is equal to 1 minus, and I can clean this up. That's a nice decimal. It's 1.002. Type it in your calculator if you don't believe me. And that's all divided by 0.002. So I got rid of some fractions, I moved the 100 to the other side, and now I have another algebraic step. I need to get rid of this 0.002, so I'm going to multiply it to both sides. And that's going to give me 0.62 is equal to 1 minus 1.002 to the negative n. We're getting there. Subtract both sides by 1. That's going to be negative 0.38 is equal to negative 1.002 to the negative n. Both sides have a negative, so I could divide away negative 1. And I'm going to get 0.38 is equal to 1.002 to the negative n. Now I'm ready to do logarithms. So I could take the natural log of both sides. I can rewrite this as a logarithm if we wanted to. There's a lot of different ways I can attack this problem. I'm going to rewrite it by taking the natural log of both sides. That's what I've noticed a lot of you have done. Using my logarithm rules, I know I can move that negative n to the front. So I have the natural log of 0.38 is equal to negative n natural log of 1.002. Divide both sides by the natural log of 1.002. And I can figure out what that value is by typing it in my calculator. So if we type it in, natural log of 0.38 divided by the natural log of 1.002. Negative 484 point something. So I have negative 484 point something. We'll say 0.3. That's good enough. Both sides have a negative, so we could say n is equal to 484.3. So meaning it's going to take 484.3 months to pay off this loan. I can't pay off 0.3 of a month, so I'm going to say 485 months. 485 months, if I was to divide 485 by 12, that's going to be about 40.4 years. So you graduate college at 22, you pay off this student loan for 40 years, you're 62 years old, getting ready to retire, and you just paid off your student loan if you pay the bare minimum amount every month. This is a life lesson. When you eventually get your student loans, don't pay the minimum payment. It'll take you forever to pay them off. Double it, triple it, whatever you can afford to do, do. The other part of this is to figure out how much more money they're going to get from you just by taking this loan out. So if you have 485 payments over the course of this loan of $100, that's $48,500. Well, the original loan was only $31,000. So over the course of this loan, the interest you're paying is $17,500. So to borrow $31,000, they're going to charge you $17,500. Seems crazy, but it's real life. That's how banks work. Hopefully this video helped. If you have questions, please reach out to me via email or on Google Classroom. I'd be happy to help, and hopefully I see you soon.